About 3D trigonometry questions are nearly 99% that we are going to use sine formula or cosine formula, something like that. So the first part, part A, should not be too difficult. They give us some of the line. It's about AC. This is equal to 13. AD also equal to 13. And also CD is also 13. So before we start, what they imply us is this plane. DAC, this triangle. This is equilateral triangle with all angles 60 degrees. It should directly come up in your mind and may be useful later. After that, they say that BC is equal to 8. BC is equal to 8. And then BD is 12. And then angle ABD is equal to 72 degrees. What they ask us to find is to find angle BAD. So we want to find out this angle. To get this angle, then of course we need the corresponding 2D diagram. So I label the plane in green color. We are talking about this plane. But this is not good in our calculation. We redraw it in 2D diagram. Assume that we vertically look in front of it. So the graph is like this. Don't draw an isosceles triangle. It's look like isosceles, but the fact is may not. So create some differences. Otherwise, you may make wrong decision. We know DAB. This is our target. And then you are trying to write down as much as information that you have. You know AD is 13. You know that BD is 12. You know angle DBA is 72 degrees. So it's very obvious that we have enough information here. We have two angles including our target and two sides. That's why we are going to use sine formula. Sine angle A to A is equal to sine angle B to B. So in this question, we have sine theta over the opposite side, which is 12. And then sine another angle is 72 degrees, and its opposite side is 13. That's why isolate theta, make it be the subject. Theta is equal to shift sine this value. Then you get 61.4 degrees. Correct to three significant figures. And then for part B, our target is to find out CP. How long is that line? For this line, is on the plane of the equilateral triangle. So we are talking about somewhere here. First, you have to ask yourself, can you use a simple trigonometric ratio to find that out? That means is this angle 90 degrees? Then you double check. They never mention this one is perpendicular. They just tell you BP on this plane are perpendicular to AD, but they didn't tell you whether CP are perpendicular to AD, so you can't use that method. In this triangle, what you know is AC equal to 13, and then we want to find out CP here. We have one angle, we have one side. We may either find out one more angle or find out AP here. Just now we work on the green plane, which is the triangle here. So we may find out AP by using this graph. If we find out AP, then we can use cosine formula to find out CP. This is our strategy. So first mission, find out AP. Second mission, find out CP by using the cosine formula. AP is really convenient here to find is because this is perpendicular. Based on the information, BP is perpendicular to AD, so it's easier to calculate. To find out AP, we have this angle but we don't have AB, so a more convenient method is find out the remaining angle. Then we use a cosine ratio to find out DP. We use 13, subtract it, we get AP. So we write down the angle BDA is equal to 180 degree minus 72 degree minus angle BAD. It's around 46.4101364 degree. And then after that, that's why dp is equal to 12 and then a shorter length, so some sine angle BDA is approximately 8.720353748 cm. And then our target is to find out AP. We use 13 minus that, so it's approximately 4.279646252 cm. So AP, we finish our first mission. This is 4.279646252. Of course, you should use your memory slot in your calculator. Now, finally, we can continue. Our final target is CP here. And then we already know 2.279846255. And then AC is 13, and also we have 60 degree because it's equilateral triangle. So our target is final CP. We use cosine formula. C squared is equal to A squared plus B squared minus 2AB cosine angle C. C squared, that means CP squared here. So CP is equal to approximately 11.4 cm. Correct to free significant figure. We have a pretty good understanding of this triangle now, and then we are going to consider part B. Is angle BPC the angle between the face ABD and also the face ACD? Just now we already mentioned a little bit is about this angle, is right angle. So that's why BP can represent the plane. This line is used to represent the plane ABD. So the problem is CP qualified to represent the plane ACD? To make CP able to represent it, we have to make sure that angle CPA is right angle. Just now the green line is perpendicular to the intercept line. Now we have to show that CP is that also perpendicular to line AD. If you have no idea at this moment, then you think about what is the connection in part A. Why we have to find out CP? We already find out CP is 11.4 something. That means in this triangle, we already have all three sides. And then we interested is whether this angle is 90 degree or not. By the converse of Pythagoras theorem, if we can prove that AP squared plus CP squared is equal to AC squared, then this is 90 degree. If not, then this is not 90 degrees. Then we can make the decision. So we are going to consider AP squared and then plus CP squared here. Then it is 152.4 something. Another part, we also consider AC square is equal to 169, which is not equal to AP square plus CP square. Therefore, we know that angle APC is not 90 degrees. That's why this line CP cannot represent that plane. That's why the claim is not correct. And where is the angle? We use BP, which is perpendicular to the intercept line, to represent the plane ABD. And then if we draw another perpendicular line, which is perpendicular to AD, it should be like this. So if you talk about the angle between two planes, it should be this angle. Or if you do not cut here, you may cut from point C. Our perpendicular line is like this, and then you have to draw this point to another point to ensure that both directions are perpendicular to the intercept line. Then that angle is also your target. If you really want to find out the angle between these two faces, then we will consider the blue line is easier to handle. The reason is we already have AP with this 60 degrees, so we can find out, let's say if this point is E, we can find out PE by using AP here. After that, you still need to consider the base plane, see whether you can find out EB. Not guaranteed. And then if you find out EB, then with three sides, you can find out the angle theta here by using cosine formula.